So thank you for joining us tonight. My name's Kristen Fletcher. I'm the Programs and Community Engagement Manager at the Haley Public Library. Tonight, Dr. Andy Speer will discuss hunter-gatherers during the Ice Age. Dr. Speer's previous talk in 2021, called Peopling the New World, is our most watched video with over 88,000 views and counting. So we're excited to invite him back for another fascinating exploration into North American prehistory. For tonight, we're going to be taking questions at the end. And now it's my pleasure to introduce Dr. Andy Speer. Andy was raised in South Texas. He received his PhD from the University of Texas at San Antonio in ecological anthropology in 2013. Following graduation, he served as a postdoctoral researcher at Texas State University in the Department of Anthropology and worked primarily with Clovis Period materials from the famous Gault site. Currently, Andy serves as associate professor in the Department of Anthropology at Idaho State University and as curator of anthropology at the Idaho Museum of Natural History. Both are located in Pocatello. His area of research is geochemical analysis of knappable stone to determine mobility patterns of prehistoric hunter-gatherers. His current work focuses on sourcing Paleo-Indian and protohistoric artifacts from the American Southwest. For this research, he finds it integral to integrate Native American perspectives as they relate to indigenous knowledge of ecological resources and archaeological findings. His other research areas focus on interdisciplinary approaches to understanding the peopling of the New World, lithic technology, experimental archaeology, ancient craftsmanship, and GIS predictive modeling. He has been an avid flint knapper and prehistoric skills enthusiast for over 20 years and enjoys fishing, hunting, hiking, and kayaking. So welcome back, Andy. It's great to have you here, and I will just turn it over to you.
Okay, thanks, Kristen. You make me sound like a pretty busy guy.
I think you might be.
I have to admit, I am. Well, thanks for having me again tonight. The last talk, it kind of got a lot more views than I thought it was going to get on YouTube, so that was interesting. And I thought tonight, let me go ahead and get this shared with you guys so y'all can see it and make sure it's working. Oh, thanks. Share screen. Hopefully it'll work correctly. Can you see that okay?
Yes, I can. Whoops, it just got smaller, but we can see it.
Okay.
Yep, that's perfect right there.
Okay, it is. All right, great.
There we go. That's excellent. Nope, it's perfect right now. Yep.
Okay.
It's got those funny black boxes that keep coming and going. I don't know why they do that, but
okay. I'm going to go ahead and stop my video, but I'll leave the presentation up, of course, and maybe this will help. Are those black boxes going now?
Well, we gained one and then we lost two. So that's perfect right there.
Okay, great, yeah. Great. All right. So I'm going to talk to you tonight about, what it meant to be human, living early in North America before anybody else was here. At the close of the Ice Age, human beings started entering the New World. In some cases, we're thinking it might have been 20,000 years ago at the earliest, but we're going to focus on basically what it meant to be human during this period of time and live as a hunter-gatherer. And I'm going to incorporate a lot of research that I'm working on currently and with my graduate students to kind of unravel some of these, mysterious behaviors that these people were engaging in the past. What did it mean to hunt a mammoth? Were people hunting these all the time, or was it like a once in a lifetime event? Was it a yearly event? Or was it a daily occurrence? So a lot of these questions, they still go unresolved to some extent. And we're going to hit, let me see if it'll, there we go. Going to talk about a few things like an overview with research, and then I'm going to introduce you to some of the the prey items that people would, live on in the past, mammoth and bison, with bison being a primary species that they would engage with and consume. And we'll talk about some of the earliest peoples in the New World and, what that meant. And we'll talk about some early sites. And then we'll talk about some of these hunting techniques that they used, in particular, using jumps and traps. And I'll describe what those are. And then also looking for answers here in Idaho and the Intermountain West on something I'm really interested in is communal gatherings and large-scale communal hunting. A lot of my research has kind of been directed towards understanding how people are hunting these really large animals and engaging with them. And, at what times of year are they doing this? Why are they doing this? Is it just for food or are there other reasons behind it? And then I'll have a summary. But, people that were living during the Ice Age, they might have very well had encounters like this. We do know that people in Europe living during the Ice Age had these, encounters where they would scare off large predators from kills and they would scavenge them. People were living with these really large animals, including cave lions, mylodon, massive ground sloths, short-faced bears, cave bears, and of course, your saber-toothed cats, dire wolves, just these really large animals that we kind of classify as megafauna. But my text will have my slides will have a little bit of text on them, but I tend to gloss over them. But you can, of course, feel free to read that as I'm talking as well. So a research overview here, we're trying to investigate the peopling of the Western Hemisphere, of the Americas. And there's lots of information about there, and it's continually changing as we have more research being done and more data is coming to light, and new sites are being discovered. And there's lots of pieces of this puzzle. There's paleoecological data, there's genetic data, there's lithic technology. There's all this information about the animals that were hunted. And there's a couple different models that are trying to explain how people populated this part of the world, up to 22,000 years ago. We do know that people made it all the way down to the southern tip of Chile by 14,500 years ago. And this kind of upset the model of the Clovis people being the earliest. Now, that's not to say that we just stop studying the Clovis people, because they're very informative to showing us what kind of lifestyle was taken by these folks to engage in an environment where you have all these megafauna. So the big question is, after people leave Asia and they leave these, ancestral homelands and they arrive in the Western Hemisphere, what does that mean to be moving into a completely new territory and making a living and being able to survive in these conditions of megafauna, and the environment is very different than it is now. So we're going to kind of look at some of these questions and approach it from a research perspective that I'm engaged in currently. So I want to kind of introduce you to an overarching hypothesis that I have. The earliest peoples that were, living in this part of the world, they definitely had a unique shared cultural identity. And my hypothesis is that they were emphasizing a periodic communal gathering. And there's reasons for this. And I'm trying to focus on Clovis because they are much more prolific in the number of artifacts that we have for them, as opposed to cultures that came before Clovis. And people would engage in communal events. We know this from ethnographic data, from ethnohistoric accounts, and we do know it from some sites where archaic patterns, people are engaging in these communal, yearly, like annual or biannual gatherings. And the reason for this is that, they're sharing information. If you're living in a small group of people, 20 to maybe 100 people, that environment that you're living in will only support so many people for a given period of time. And at some point, you're going to exhaust those resources. You might kill all the deer that are locally available to you. There might be a limited amount of things that you can gather, like plant material, nuts, berries, all those things. Those are highly seasonal. And, there are also things that there's only so much of it per unit of land. So that carrying capacity of the land to support a number of people, it can't support larger groups. And because of this, people need to branch out for things like mate selection and finding people that are outside of their group to mate with, and then, marry and have kids, things like that. And what's interesting about this communal gathering time period is that they're sharing information, they're selecting mates, but there's all kinds of other activities that might be going on at this time. And one of those is large-scale communal hunting of megafauna. And that's something that I'm really interested in looking at with what it meant to be a hunter-gatherer at the end of the Pleistocene. So we're going to look at a couple different things here tonight, and I'm going to present to you some of the information that we're currently collecting to kind of bring all this information to bear and help us maybe point out that, these communal gatherings were a real thing during the Clovis period, and people were engaging in activities and behaviors that emphasize, hunting large game, hunting things like mammoths, things that you might not do because they're too risky at other parts of the year where you've only got maybe 20, 50 people living in a group. You might have as many as 100, but in some cases it might be too risky because you only have so many able-bodied hunters available. So we're going to look at stone tool sourcing. We're going to look at what is a megafauna trap and a jump. And we're also going to talk a little bit about understanding animal migration patterns. And all these things together are going to form very important lines of evidence to help us understand these communal gatherings when people come together and can do these really interesting things. So that's basically my overarching hypothesis. And because of this hypothesis about what do these communal gatherings look like, we got to gather a lot of data. And to gather that data, we have to ask research questions. Excuse me. So a couple of things pop up in the archaeological record that actually maybe start, questioning these things and asking, why is this behavior present? Is it because of this, large-scale communal hunting? And one of these things is a diversity of material in some stone tool caches. On the right, you see there, this was from Pete Bostrom's website, Lithic Casting Lab. This is the Fen cache, and the Fen cache was found at the Utah, Wyoming, Idaho border. And it's not exactly clear exactly where Forrest Fenn found this cache, but what is clear is that it is real, it is all Clovis age material, and it's incredibly diverse. So why do people bring all this stuff into one location and deposit it in the ground and it gets left behind? Was it forgotten? Was it for insurance purposes on a hunt? Was it sacrificial in some way where they're, giving their best material left behind? A lot of archaeologists have argued that this is probably some of the most high-level skill of Clovis lithic production that's ever been done, including some that might be the most artistically pleasing or aesthetically pleasing. So a lot of questions start coming into play then. We've got the diversity of stone tools, but what about things like seasonality and animal migration patterns? Does that maybe affect the timing of these communal gatherings that I'm hypothesizing? Is there some type of preferred communal hunting practice or strategy for different megafauna? Do you drive them over a cliff? Do you catch them in a bog or along a lake shore? Do you dig a deep hole so they fall into it with sticks in it? All these things we're trying to understand that are possible, and can we test them archaeologically? Can we find this evidence? Also, do we see changes in technology that may influence communal hunting practices? So looking at the transition from, Clovis to Folsom, what is the changes in technology there that might affect these communal gatherings? And then, of course, are there regional variations in communal hunting practices that are based on some of these ecological differences? Because, if you don't have cliffs to drive the animals over, you might have to find other alternatives to figure this out, to trap or corral them somehow. And then another thing that's another very important line of evidence is, how does the use of fire and what we call anthropogenic fire influence communal hunting success and landscape management? So a lot of the ideas that I'm investigating with different methods are people using fire both to drive animals, but also potentially to serve as bait. When you burn the landscape prior to a large communal gathering where you can have these big hunts, you're providing fresh green grass. So if you do that a month, 2 months ahead of time, or maybe even the year before, you're providing a space that will draw the animals in so you can exploit them in these large scale hunts. So some of the techniques that we're using to answer these questions that I'm posing to you tonight, we have the traditional methods in archaeology with excavation, analysis of sites across North America, looking at lithic assemblages and looking at all the stone tools and site stratigraphy. Now, that information can get you a lot of lines of evidence to answer these questions that I'm posing to you, but we also turn to other methods that'll help us extract more data from the archaeological methods that we traditionally use. And one of those is isotopic analysis, both strontium and oxygen isotope. And there are a couple other isotopic methods that we use. Tonight, I'm really just going to focus on talking about strontium isotope sourcing in particular. But I'm going to allude to a little bit to, we actually received a large NSF grant that I wrote. We got funding for it last year, and we're getting this really awesome instrument that'll let us do a lot of these analytical techniques right here in Idaho. And it'll be one of only 3 in the whole world currently available that can do the kind of analysis that we're going to do. And on the other side of that coin is, sourcing stone tools and using that instrument for that purpose as well. And then ecological methods. So looking at reconstructing paleo environments. What did Idaho and the Intermountain West look like at the close of the Pleistocene? Were there as many pine trees? Were there oak trees? What kind of nuts and berries could they gather? All those are questions that kind of frame the overall idea of these communal gatherings that I'm talking about. And then also we can turn to geoarchaeology for reconstructing some of these sites and looking at areas around where these animals may have been hunted. So what do we already know? Well, we have our archaeological data, right? We've got collections of stone tools. There's been research going on lots of Clovis caches throughout the years, and we can look to those with stone tool sourcing to really focus in and figure out, okay, where did this group of stone tools come from? How diverse is it really? We look at site reports, so things that people have already done at other sites, over the past 100 years or more, possibly, looking at these Clovis sites. And then using isotopic data, like I talked about, we can start reconstructing migration routes for animals. We can use strontium isotopes to extract the movement patterns of different animals and possibly even people if we have access to human remains. And this is not only for North America, we can do this for other areas as well. Here on the right, you actually see some recent data that I got using one of the instruments that's in England at a university there that is very, very accurate. These are individual pieces of rock where I've taken flakes and then I've taken one of those rocks and treated it like an artifact. And then I tested with the instrument, and I'll talk about that in a second. But we get these really tight groupings of a single rock. And this is really groundbreaking because we can start using this data to figure out where on the landscape people were getting their rocks and creating their tools and then moving them off site of where the source is. So there's a lot of exciting things that we can do with this technology. Using ecological data, things that we already know, we can look at these investigations. This is an image from the early 80s at a bonfire rock shelter that's in Texas in the lower Pecos area. This is the main excavation area. And, this is a bison jump that we're going to be talking about here in a minute. And we can look back at all the field notes and site reports, and we can look at the skeletal collections and the stone tools, and we can start reconstructing what was going on at this site and compare it to other sites throughout North America. And there are other scholars that are also doing similar studies to this that have been ongoing for quite a while now. So we're going to be looking at this from kind of a zooming out a little bit more than other people have worked on. And a big part of this is going to be GIS. So GIS is called Geographic Information Systems. And this is where we can have data sets that will assist us in mapping out all these layers that we have at archaeological sites and the adjacent areas. So we potentially could, zoom out and look for potential migration routes. We can map environmental features like, are there cliffs in the area that could have been a bison jump? How close is a Clovis cache to this site? Other Clovis sites, are they available in the area? Are there other kill sites in addition to a potential, large-scale communal hunting like likely happened at Bonfire Rock Shelter multiple times in the past? And continuing to like the data that we need to collect, excavation is very important to us. And we will be drawing, I have some excavations that are going to be starting this summer actually at Castle Rock State Park. And we're going to start investigating some of these maybe deeply stratified sites where we can get down to this Clovis material that'll be intact and look at the stone tool assemblages and see distance to source and start filling in a lot of this data that's missing for much of the Intermountain West and especially Idaho. We'll also be conducting site surveys, looking for new sites, including potential bison jumps, very importantly, and different kinds of ecological zones, and looking for those regional differences in hunting activities. And then, of course, going back to the isotopic analysis. And I don't know if you can see my the pointer here or not, but this is an experiment I did with the new instrument we're getting. This is the instrument that I was telling you about that's in the UK. We have stone tools like this that I created, that I napped myself. I created the stone tool, and we put this under this laser, and it seats to this where we get like a soft seal. And this is going to let us achieve a lot of things that we want to achieve because of the very high resolution of the instrument. So other data that we need to collect, sediment analysis, looking for landscape modifications, the use of fire, again, site stratigraphy like I talked about, GIS mapping, so that's plugging in everything that we previously mentioned, and topographic mapping, looking for areas that might have been favorable for bison jumps and having potential travel routes. So something I need to clarify here is that when people would use a bison jump, that doesn't mean that they would use it and the archaeology would automatically be present there that we're finding. These sites might have been used as a jump, but there's no archaeological evidence present because it's simply been washed away or it's no longer exists due to the vagaries of time. So that's something to really think about with, we have places on the landscape that might have been utilized. How do we identify those? How do we use things like topographic mapping, spatial analysis, sediment analysis to see if potential areas were used to drive these animals up over these cliffs or into traps or into corrals? We need to look for other lines of evidence instead of just at the base of a cliff and hoping there might be archaeology there, because sometimes it's just bare rock. So these are things that we're trying to explore and look for other lines of evidence to kind of connect the dots for us. So now let's shift gears a little bit and talk about some of the animals that these folks were eating. And in particular, the reason I'm focusing on mammoths and bison is we really want to look at those animals that might have been used as a novel species to hunt, but also they could feed a lot of people. This doesn't mean that Clovis people were hunting only mammoths and bison. They had a broad spectrum diet. They ate lots of different animals. They ate lots of different plants. So I'm going to introduce you to mammoths and kind of fill you in on some of the characteristics of these animals, because if you understand the animal and the way that the animal behaves, then you can understand some of the hunting behavior behind it. A lot of times people get mammoths and mastodons confused. On the left there, you have a mastodon tooth. On the right, you have a mammoth tooth. These two animals are different in the types of materials that they are consuming. The mastodon on the left, the rounded teeth that you're seeing there, that's for tearing into food because they lived a slightly different existence than mammoths. They are living as a browser. So they're eating things like bushes and leaves, and mammoths are consuming a lot more types of forage that's on the ground. So they're more type of a grazer. They might have switched both back and forth, but you can tell just by looking at their teeth. You see a browser on the left and a grazer on the right. And that's not to say these animals couldn't expand their diet a little bit, but for the most part, that means this is the main source of calories they're consuming during the day, is a browsing versus grazing diet. So we can also tell different species of mammoth by looking at the number of ridges on the teeth. So I'm going to give you more mammoth facts here. They obviously, they've got tusks. They sometimes can be extremely long, sometimes in order of 16 feet long. And the tusks are simply elongated incisors. And they have a prehensile trunk. They're very large animals, of course. And some of this criteria of these animals is going to help us use archaeological information and even zoological and paleontological information to reconstruct some patterns in the past. Mammoths, the earliest ones made their way into the Western Hemisphere quite a bit later than typical. You have your mammoth that we're going to focus on, the Columbian mammoth. That evolved from the steppe mammoth. And the Columbian mammoth, they're coming from this population of steppe mammoths that made their way across the Bering Strait around about 1 million years ago or so into the Western Hemisphere. And when they did that, the steppe mammoth, it's adapting to new environment. Some are surviving and passing on their genes, others are dying out. And those animals are gradually changing over time into the Columbian mammoth that we know people were exploiting and hunting. To give you an idea how big these animals are, the one on the right there, this is a monumental bronze that's at the Washakie Museum and Cultural Center in Wyoming. And the Colby Mammoth kill site that's close to there is a reason for this center that they developed. Close projectile points were covered at this site, and people were obviously hunting this animal, and they were finding ways to safely harvest these animals. So just to give you an idea, you've got a guy standing right there in front of it. These are very large animals, and they're extremely dangerous. And when you think about the small size of groups that people were living in, you got to be really careful around these animals. You don't want, any of the people in your group to get hurt or injured or killed, obviously. So you got to come up with unique tactics and strategies to hunt these animals. The Columbian mammoth, it died out about 10,000 years ago. And there's some evidence that the Folsom people may have encountered a few of these, but they were probably extremely rare. During the Clovis period, they were probably much more plentiful. And the Columbian mammoth did not have the long hair like you might be thinking about with the woolly mammoth. But it was about 16 feet tall at the shoulder. The Columbian mammoth was about 15 feet long or so, and it depended on the animal, if it was a bull or a cow. But they did weigh up to about 22,000 pounds, so over 10 tons. That is a lot of food for people to consume. So if you have a small group of people that kill one of these things, you got to find a way to process the food. Is it worth the risk? And that's where these ideas are coming from about these large communal gatherings where you have a lot of people. And maybe mammoth hunting is a novel situation where when you have, several hundred people and you're going to feed them, what better way than to go on this really interesting hunt and come up with cool strategies to take this animal down and benefit from it. So elephants today, we use a lot of information about their social behaviors, African elephants and Asiatic elephants, to kind of model in the past how mammoths and mastodons may have acted. Something a lot of people don't realize is that elephants take a very long time to bear their young. It takes almost 22 months of gestation for an elephant to be born. So when people are, potentially killing these animals are not being replaced quickly enough, possibly. You combine that with shifting climate, and a lot of these animals start dying out, like the Columbian mammoth did. And some characteristics of them that they likely did live in this mostly adult female herd with their calves. And the males would typically leave the herd after reaching sexual maturity. The males would probably either live alone as a bull or they live in bachelor groups. Now, there are things that we don't know that are debatable, such as seasonal mating activity, or are they only seeking out each other for mating when they're sexually active? That is possible for these animals. It is thought that these animals live to be about 70 or 80 years old. So these animals were probably migratory as well. And that's something that we're going to figure out for here in the Intermountain West, is trying to track how these mammoths were moving through the landscape. And were they, these female groups that had this really deep knowledge, and they would continue following the same routes year after year, and then it'd be passed on to their young. Now, elephant diet, talked about this a little bit. The Columbian mammoth, it subsisted, on a lot of grasses. It did occasionally eat brush, sedge, small trees. But these animals, and I don't think people ever realize how much food these animals have to consume. It is a lot of food. It's on the range of between 130,000 and 150,000 calories per day. And remember, they're trying to get this from grass and vegetation. That is a lot of food that they have to consume each day. And you're talking on the order between 14 to 16 hours of eating alone and hundreds of pounds of food that they have to consume. So when these animals move through the landscape, they're going to be wrecking the whole landscape. It's going to be obvious that you've had elephants come through here because they're consuming a lot of vegetation. They're knocking things over. They're doing all kinds of stuff. And like I said, they're dangerous animals. But when you start thinking about these things, about how much they have to eat every day, you can start coming up with strategies and ideas about how to potentially hunt them. I already talked about Tusk a little bit, just to give you an idea with this picture. These are very large, dangerous animals, and if these things swung around, they would easily kill a person. Um, we're going to come back to the Tusk in a few minutes, but to get an idea that these animals are constantly growing these things. A full-grown bull could have a 16-foot long tusk. And you're going to see in a minute that the tusks are going to be important because they're constantly growing throughout the animal's lifetime. And this could be anywhere on the order between 1 to 6 inches per year that is continuing throughout their lifetime. It does start to slow down a little bit when they reach full adulthood, though. Now let's switch over to bison a little bit. Bison species, they were variable at the end of the Pleistocene, from that 20,000 to 10,000 year period. The one that most people would have been encountering is Bison antiquus. It's debatable how much of Bison latifrons, like the one you're seeing here on the right with these really, really large horns. Bison latifrons was extremely large compared to some of the other bison, but it's limited evidence that people were actually predating this animal. The one that we are interested in is the one that's second after the Bison latifrons is a Bison antiquus. And Bison antiquus remains are found at many archaeological sites, many Paleo-Indian sites that are very early. And that's the one that we're going to look at the most. But I thought this was a good idea. If you've ever seen a modern bison in person, this is your modern bison, called bison. That's its scientific name. And the extinct Bison antiquus is quite a bit larger, 1.5, in some cases, a very large male. It'd be extremely large animals, also very dangerous. Give you another idea here of some of their physical characteristics. You got a 6-foot tall person standing there. These animals, of course, didn't weigh as much as mammoths, but still 4,400 pounds. They had curved horns that could reach out to about 6.5 feet long from tip to tip. They had really thick, shaggy fur. So you think about hunting an animal like this, it might be difficult to penetrate the hide of it. These animals are very fast as well. We're talking just like a racehorse. And these animals could easily kill some as well. And they lived in a herd structure for the most part. They're found throughout North America during the Pleistocene. The habitat ranged from grasslands to forest. There are bison living in very cold conditions, bison living in deserts. They're all over the place. And the modern bison that you're familiar with today, these likely are derived from Bison antiquus here on the right. So by about 10,000 years ago, Bison antiquus started declining in numbers. This is probably also due to climate change and overhunting by early human populations, but the animal kind of survives on in bison, these smaller species, likely due to climatic pressure and the overhunting by humans. But this animal played a significant role in people's lives. It not only provided them with food, but also their clothes, lots of tools that you can get from the animal's skeleton. This is a picture of a Bison antiquus staring at you like it's about to charge at you. The animals were just extremely dangerous. So to engage these for your everyday sustenance would also be very challenging and very risky. So you got to come up with ways to potentially take these animals out. The ecological role of bison, it can not really be discussed without talking about how it's shaping the environment. It is constantly changing the way that the landscape looks. It is a keystone species. It is vitally important to a lot of the ecosystems that were developed during the Pleistocene. You can actually see it after bison are wiped out in the 1800s in the Great Plains. The Great Plains start to change because these animals are no longer present in the numbers that they were. You're talking hundreds of thousands, if not millions of animals that are moving through these environments. Their grazing habits had a huge impact on vegetation communities, and they really shaped the grasslands that, when the Spanish arrived in the New World and they were, riding up through the plains in the 16th century, and they're seeing these vast grasslands, it's because of these type of animals. And another important part, it's really hard to wrap your mind around sometimes, but they're not only shaping the landscape in some ways, but also the nutrient cycling. Their movement patterns are basically taking the vegetation and redistributing it throughout the ecosystem. All their poop, they're trampling on the ground, they're making those soils incredibly rich, and they're causing the ecosystem overall to be very healthy and resilient. So anytime there's fluctuation in these bison numbers, you're going to see shifts in the carrying capacity of the land, and if human beings can even survive in some of these areas without these animals being a keystone species. So some on bison behavior and social structure. Bison today probably act a lot like bison antiquus did in the past. And here's a picture on the right from spring 2023 of some of the Yellowstone bison herds. They have your typical hierarchical structures. They have social bonds. They have some cooperative behaviors. They defend against predators, and there is resource sharing, but there's definitely a hierarchy in the herd structure as well. There is seasonal movements of these animals, and they have clear migration patterns. They get driven just like every other animal by the availability of food and climatic fluctuations and their reproductive needs. So this animal in particular is important to our understanding of how people would have been managing the landscape in the past as well, how they would have been surviving as hunters and gatherers. Communication and behavior within a bison herd, they have all kinds of different grunts and snorts and vocalizations. They put out all kinds of scents, both in their poop and their urine. They have scent glands on parts of their body. And, all these animals are, they're on the move, just like your mammoths are. They're consuming a lot of vegetation to survive. I feel like maybe I should take a quick break and ask anybody if they have any questions at this point. Does that sound like a good idea, Kristen?
That sounds fine. We have a pretty modest sized group, so if you're interested in asking a question at this point, go ahead and unmute yourself, and we'll take maybe 2 or 3 questions. Does that sound okay, Andy?
Yeah,
okay.
that sounds great, actually.
Right. Anybody have any questions at this point?
No questions yet? Okay. Well, I'll keep going on, and since we have a small group, if you do have a question, don't hesitate to put it in the chat or raise your hand with the function or whatever. So now let's transition to the earliest peoples. Talk about a few archaeological sites and some stone tool assemblages, and a couple more questions about who were these people and how were they surviving. Click back on there. There we go. So one of the earliest examples we know of a Clovis site is one coming from 1929. Now, when it was discovered in 1929 at Blackwater Draw, this site was not known that it was probably one of the earliest in North America. Folsom points were being found, Clovis points, all kinds of fluted points were being found. It wasn't really clear that Clovis was first at this point, or was one of the earliest to be found, bracketing that 12,900 to 13,200 years ago. But amateur archaeologist, he found this dried out ancient stream channel just outside of Clovis, New Mexico, hence the name Clovis culture. And he found these little chiseled stone points, with the flute. The interesting thing is that they were also found with mammoth fossils. So you've got people that are hunting mammoths now in North America. This is a big game changer for understanding how people were living here prior to colonization. This is a very big story about people very early on, because obviously no mammoths had been found in the region for at least 10,000 years, and no one had ever even heard of them. So a couple of the sites that you're seeing here, this is showing clear evidence of people hunting mammoths or mastodons. And you can see the confirmed information it's a little bit sparse. There are quite a few others that could go on this map, but these are ones that are very significant. And it's not a whole lot. You would think that if people were hunting mammoths all the time, there would be more archaeological sites, because finding mammoth fossils is not that hard. They're very large. So from the Blackwater Draw site, we get this idea of what Clovis culture was. And this is what kind of develops this story about Clovis people being these, megafauna hunters, that they're killing mammoths and they're killing giant bison. And, it becomes this idea that gets entrenched in archaeology. And we know now that people that were living during this time period that all shared this idea of the Clovis Point and the way that it looked, it was a shared cultural identity. But these people were living in vastly different environments and ecological zones. They were engaging in some of the same hunting practices, but they were a very diverse group of individuals. And all of them probably had a broad spectrum diet for the most part. And all this is based on current archaeological evidence and understanding of, we're finding all these other animals that they're eating. We're finding evidence of them eating a lot of plant foods as well. So Clovis points or skeletal damage that is being found on these animals at Blackwater Draw is really leading archaeologists into this kind of skewed picture of what it meant to be a hunter-gatherer living during the Clovis period in North America. You can see here on the right a significant number of bones that are scattered throughout the site here, including ancient bisons, so Bison antiquus. And that brings us to this idea of the Clovis technocultural complex. It is a shared technology among these people. And the Blackwater Draw site is the type site. So we're finding these points there and we're creating this template of, okay, this is what Clovis culture is. It's based on this morphology of a projectile point. And the morphology, of course, the obvious thing is that they all share this flute that's coming up the middle here to facilitate hafting of the point to a spear to go out and hunt animals. So a lot of the work that was done at the Blackwater Draw site, has been sporadic throughout the years. But the three largest ones that you're seeing here, those were found back in the 60s. And the widest point that you're seeing right here, this really big one, that was found inside of a mammoth's body cavity. So all of these were actually found with the mammoth, but this one was actually inside the body cavity. So that is the smoking gun. It's also a good example, like I teach my students to, leave artifacts in place, because if someone had taken this outside of that mammoth chest cavity, it would have lost its context. If someone just came out and collected it and took it away, you'd never know that people were hunting this mammoth there. You'd see all the stuff that'd be on the outside, but this is the most important part, because it verifies that people were hunting these animals and it was possible to kill them. And the smallest point that you're seeing here, this little guy right here, that's made out of Edwards Plateau chert. It's something I've worked on for many years, trying to geologically source these projectile points. And at the Gault site, a site I'm going to talk about here in a minute, I sourced all the projectile points from there, which led to some very interesting conclusions. So throughout the southwestern United States, Clovis points have been found stuck in the ribs of mammoths. If you go back east, a lot of these points are being found with mastodon skeletons, because this is a different kind of environment, but they are still Clovis points. And it's likely that, the people that were living in these places ate a large variety of plants and animals, like I've said, that broad spectrum diet. Here on the left, this is a projectile point, Clovis projectile point that was found at the Naco site in 1952. And you can see here some of the mammoth remains, there's rib fragments and different miscellaneous bones that are scattered throughout there. So tracking the first Americans, when you have all these mammoths that have evidence of being hunted, and it's very early, when you have the advent of radiocarbon dating, people start figuring out, okay, wow, this is really old. This is like 11,000, 12,000, 13,000 years old. Some of these animals are being hunted. Okay, where did these people come from? Did they come from North America originally? Did they evolve here on their own? Are they coming from Asia? Are they coming from Japan? Are they coming from Polynesia? There's lots of questions about where these folks came from. And a very common argument in the past has been that people came over from Asia across the Bering Land Bridge. And now this is completely possible and it's plausible, but something a lot of people fail to realize is that people coming into North America from Asia was not just one single event. It has happened multiple times throughout history. It's probably been multiple occurrences. Some people think it was like 9 different pulses or 12 different pulses of populations coming across the Bering Land Bridge or even by boat, skirting the coastline, making their way into North America. But we do know at different periods of time, the ice sheets that were blocking the way from Asia to North America opened up at some critical points in time. And it might be then that these people were making their way into the interior of North America. And we do know, like I said before, at 14,500 years ago, people were living at the southern tip of Chile. So a lot of the evidence that's come to light over the past 30 years has really changed our ideas and concepts of who the Clovis people were. And importantly, it makes us understand that they also have cultural traditions that they're coming out of. They're not just one day all of a sudden there's Clovis culture and someone comes up with it. Like they are a part of a continuum of culture where these ideas may evolve in situ. And something that's been in the news recently, I thought I'd talk about this a little bit. There's a lot of debate about the White Sands footprints. An article came out recently that kind of debates this very old age. These are footprints that have been dated to some of the original papers, and those have been definitive between 23,000 and 21,000 years ago. There have been some other scholars that have argued against this and put it closer to like 17,000, maybe even 16,000 years ago. And regardless, this stuff is still before Clovis. These people are living very early along a lake shore in White Sands, New Mexico. And this points out that people were living here during the Pleistocene, and they weren't here just at this transitional period where we were getting out of the Ice Age. They were living here during what we call the last glacial maximum. So this starts opening up a whole new set of ideas and questions about how in the world are these people interacting with all these megafauna that are here? How are they hunting these animals? Where's the evidence? Where's the lithic technology and culture of these people? If Clovis is so obvious, what about what came before them? Why don't they have some obvious stone tool technology, a technocultural complex like I showed you with Clovis? The Cooper's Ferry site, this has also been in the news in the last couple of years. A site in northern Idaho, very early. These are some of the stone tools that have been found there. Lauren Davis, archaeologist that worked there, doing some great work and showing that this is a cultural tradition that is not Clovis, but is called Western stemmed. And what you're seeing here with A, this is kind of your prototypical look of the base of a Western stem point. And all these are also very early. You can see here on the left in this slide, some of the Western stem projectile points. This is all from Davis's article in Science. And you can see a proposed route here for people coming in from the Pacific and skirting down the coastline and then making their way all the way up the Columbia River to end up occupying for a time the Cooper's Ferry location in northern Idaho. On the bottom here, you see some of the excavation pictures of the Cooper's Ferry site. So this is all adding to this very important story about these very early sites. And now shifting over to the Gault and Deborah Friedkin sites, I worked at the Gault site as a postdoctoral research fellow. I did my dissertation on all the projectile points from the Gault site. But the Gault site is also very old. It's pushing back to 17,200 years at its maximum. And what's really odd about this is that all the artifacts that are found that are older than Clovis, like you're seeing here in this image, is not very evident a distinct style of projectile points. You don't have a cultural mental template that people are using like you have with the Clovis projectile point. And this brings up a lot of questions because there are small little projectile points found like H and I here in this image at the left. There are relatively small cores that flakes are being knocked off of to use as cutting tools. They do have scrapers, they have adzes, they have different kinds of tools that are also shared with Clovis, but they don't have that, hallmark distinct fluted point present. So the question becomes, why weren't these people practicing that same technology if they're living in such a similar type of environment? Is this because, in my opinion, they weren't engaging in these large communal hunts, that they weren't doing, these really amazing works of art and, possibly even competing with each other and creating these massive projectile points that have these really distinct features that are shared widely across the whole of North America? So these things, kind of start making a person ask questions like, well, why are they not having this more shared ideology among themselves? There have been similar points found in sites in Mexico near mammoth skeletons between 10,800 and 14,500. And this is a much more diverse toolkit in some ways because of the type of projectile points that are located in this. Remember, this is much earlier than Clovis. We're talking on the order of 4,000 to 5,000 years, as well as at Cooper's Ferry. So now let's get into some of these hunting techniques for hunting these big animals. We know that people are present. We know that they're hunting these animals during the Clovis period. Okay, now how are they taking these large animals down? What are some of the ways that they're doing this? And we're going to look at jumps and traps for this discussion. There are other techniques out there, but it would obviously take way more time than we have tonight. But here's a bison jump that you have in Alberta, Canada, called aptly named Head Smashed In Buffalo Jump. This is an archaeological site where bison remains have been found. So what is a jump? Well, a jump, a lot of times you'll hear the word buffalo jump or bison jump. It's also known as a game jump because other animals could have been pushed off of, cliffs to their demise at the bottom for people to then harvest the animals. And we know that people use this technique globally. There's evidence all across Europe and even parts in Africa where people would have these game drives. And one that always comes to mind in France is they would drive horses off of cliffs. The Laissez-Loutre site is an example. There are many others where you're talking hundreds of thousands of horses, probably since 40 or 50,000 years ago, were being slaughtered wholesale for people to engage in these game drives to take them over the cliffs. And when you drive a herd over a cliff, that's a lot of animals that get killed. Now, that's not to say that people weren't wasteful in the past. They were every bit as wasteful. They had the same emotions and feelings that we do these days. They could be just as lazy and wasteful as the rest of us. But the question becomes, is it worth your time and energy to drive a whole herd over a cliff? And then you have all these animals to harvest. If you're really hungry, obviously you try and do it, but there are other ways that you could get food without going to all this, expense. So the method obviously was to get a large number of animals very quickly. You get food, hides, bones, other resources, like I said earlier. The one you're seeing here at the right, this is the first people's buffalo jump. This is the Olm Pishkun site, also known as the Olm Buffalo Jump, and that's in Cascade, Montana. The jump process, so when you start thinking about, okay, how in the world would a person, even come up with this idea to start driving, hundreds of animals over the edge of a cliff. How do you do that? How do you force animals that are weighing, 3,500, 4,500 pounds to get them to move in the direction you want? So this starts out with planning and selection. You got to choose your locations carefully. It's got to have the right topography, right? You can't just have a large cliff sitting there and you expect the animals just go run off of it for you. If they see the cliff edge, they're probably going to divert and run away from it. So there's got to be a lot of criteria that's going to trick these animals into jumping off of that cliff. And this comes down to things like, well, is it the right height? Is it the right slope? Okay, we found a location. Now, how in the world do we get these animals to go to that location? So there's lots of different techniques they could have used to drive the herd. This could have been things like simply natural features. They found a really good spot and said, okay, let's scare them that way a little bit. They could have created artificial features, like they could have piled up rocks. They could have used fire. That's a thing that I'm really investigating, is people burning landscapes to drive these animals, or simply to attract them to an area. And I don't know if I have time to get into that, but some of the techniques that we're developing are looking at these kind of criteria. So the jump process, stampeding over the edge, I mean, that's what you want, right? You want them to jump over the cliff edge. You want them to fall. You want them to die. That way you don't have to get gored or, trampled or anything like that. And then, after this dramatic process of stampeding the animals, you got the really hard work that begins of processing that harvest. And I don't know if any of you have ever, processed an animal after hunting it, but it is a lot of work. For a mule deer, it's a lot of work. For a bison, it's a lot more than a mule deer. You think about an elk and how large they are. A bison is obviously a whole different animal, but it is a lot of stuff to process. And it takes quite a few people even to roll these animals over on their side. You think about a modern bison, now multiply that by 1.5 or 2, and it's even a more challenging aspect. This is from the Red River Buffalo Hunt Diorama in the Manitoba Museum. If you ever get up there, it's pretty cool to check out. And that brings us to a trap. So we've got our jump, and that's really dramatic and really cool. But people also had different ways of tricking these animals to where they won't be in that much of danger when they're hunting them. Bison trap was also it had criteria, right? It had to be in the right location, and you had to get animals to that trap. You could make a trap and you could probably sit there for a whole year and an animal might not ever fall into your trap. So there were things that they might have done, like using a corral or like doing brush structures to kind of filter these animals and funnel them down into a location. Here on the right, this is a Paleo-Indian bison bone bed at the Casper site in Wyoming. And, some of these locations are really interesting. You have these like deep little bowl-shaped sand dune features that occasionally would be used as well. So some of the trap processes, different ideas. An arroyo is one. You've got this, creek that you're running the animals into the creek and then it ends up in a dead end. It's a great way to trap these animals with hunters standing up above. You spear the animals down low. That's one way to do it. All kinds of V-shaped structures. We know there is archaeological evidence of rocks being used. A colleague of mine, Ashley Linke, she actually works in the Great Lakes region, and they found submerged, hunting blinds and corrals and things like this to drive animals into. Some of those might have been used for reindeer potentially or other animals. Having funnel-like corridors, you're trying to get them into an area where you can kill them. And an arroyo, it can be an enclosed area. If you got a dry creek bed that's got a nice little, cul-de-sac to it, or it's an oxbow, that's a great place to pile up a bunch of brush on one edge, and then you've got the animals trapped. And obviously, all these take strategic placement. You got to know where the bison are going throughout the year. And all this is going to play back to when I talk about using mammoths for tracking them, about understanding these migration patterns, because these people in the past were probably moving with these herds at certain times of year. And they had to know these migration patterns and how these animals were moving across the landscape in order to even construct these traps. So now that brings us to looking for these answers to these questions. We've got all the information available to us now. How do we start putting all this stuff together? What data do we have to collect? How do we collect it to understand if people were possibly engaging in this large-scale communal hunting that I've been talking about? And to do that, they have to obviously gather beforehand. And they're going to be sharing that information like I talked about. They're going to be having mate selection. In my mind, I envision this kind of being like almost like a family reunion or like a festival, or, I don't know if you've ever seen like Highland Games. All these people come together and it's like this big kind of festival type of environment. You might have hundreds of people present to engage in these really big hunts. And it might be, a yearly or a biannual experience when these things happen. So how do we, prove this correct, this idea that I have? So what I offer up is a three-pronged approach to understanding Clovis communal gatherings. A couple things that we have to figure out, and remember, these are just pieces of a much larger puzzle, and this is just work that I'm doing. First, hunting techniques. We've talked about those already. Stone tool caches. Why are people storing groups of stone tools in the ground? Why are they burying them? Is this for this large-scale communal hunt? Is it sacrifice of some kind to, mitigate your luck during the hunt so everyone's safe? And then also the animal migration patterns. So how do we get at these different things? How do we understand the hunting techniques, the migration patterns, the stone tool caches? Why are they so diverse? And you've got a bunch of stone tools deposited in one place from all over. Is this a bunch of people coming together and converging on one area, and they're all putting their best stone tools together as kind of like a sacrifice? These are things that puzzle us as archaeologists. And how do we bring it all together? Well, this is where I'm engaging a couple different research perspectives, and I've talked about this already, is trying to investigate the burning and modifying the landscape by using geoarchaeology and looking at potential burn patterns through time in the landscape, taking core samples, trying to locate traps and bison drives, looking at ethnographic data, so like historic accounts of people observing Native Americans in the 1800s hunting bison. Granted, they were mounted hunter-gatherers then, and they weren't engaging these animals on foot, but maybe they were using some of the same techniques and strategies and locations that their ancestors had been using for thousands of years. That's something to look into. And that's why we're looking at ethnographic data and these ethnohistoric records, but also conducting soil surveys to kind of confirm that these areas were indeed used many, many times throughout thousands of years. And then next is using GIS. So ArcGIS is just the program for geographic information systems, but we can start identifying some of these locations on the landscape that might have been used as bison jumps or even drives based on the topography, based on distance to water source, based on slope. I have several of my graduate students right now that are working on their master's thesis that are doing this very thing. We have archaeological sites that are known as bison jumps. We're taking that criteria and we're trying to apply it to areas that we don't know about. So we're doing that predictive modeling that Kristen mentioned at the very beginning when she was introducing me. We're trying to figure out where some of these sites might be, because there might be a cliff, like I said at the beginning, and there might not be any dirt at the bottom of the cliff for us to excavate. That doesn't mean that people might not have used that cliff in the past if it was an ideal location. That just means there's no archaeology present. So that's where we turn to these other techniques and strategies of like soil survey and using stone tool sourcing of maybe archaeological sites that are close by to these bison jumps or these drives. And that's where we turn to the instrument that we're acquiring at ISU. We actually just had our laser delivered 2 days ago at the university. We're going to get our mass spectrometer soon. I'll explain what LAICP triple Q MS is, but basically this is a technique that we're using to determine trace elements that are found in stone tools to match them up to their geologic sources. And also, some early research I'm doing is taking mammoth tusk. I've got about 17 mammoth tusks from throughout Idaho right now that I'm going to start engaging with strontium isotope sourcing using this new technology that we have available to us now. And hopefully, it's going to be some very exploratory research. We're not confirming it that we can actually do this on this instrument. There are other techniques that we can do strontium isotope analysis on, but the one that we have right now, it might be a real game changer in our ability to do this. So that's some of the approaches that we're going to use to answer these questions. So up first is stone tool sourcing. So we're trying to understand mobility patterns of these people living during the Clovis period. And they had an advanced stone tool technology. Their communities, they were sourcing their materials strategically. We're seeing that in a lot of these caches that are deposited on the landscape. And that really shows that these people were probably here for a long time. They had an in-depth understanding of where all this rock was to acquire, where was the best stuff. So we're not only going to be looking at chert and flint, but we're also going to be looking at obsidians as well and see exactly where these people are getting their material from. And that's where the instrument that I've been telling you about comes into play. And that's for the trace element analysis. And that's where we can get unique signatures from Clovis artifacts and figure out exact distances to how far these things have moved across the landscape. So finally, to give you a little introduction to what is going on with this instrument I'm telling you about, it's simply a way of looking at what a rock is made of. Cherts and flints, they're typically over 90% silica, and they're made up of 10% other stuff. A really good piece of rock that's good for making stone tools, it might be like 97, 98, 99% pure silica. You have your obsidian, which is a volcanic glass, which is, probably the best, but that material doesn't keep a sharp edge for very long. So using chert and flint and different agates and things like that, those can have durable edges that are very strong and they're less likely to break. So how do we analyze what these rocks are made of and get these trace elements? Well, we use a method, and I know it's a mouthful: laser ablation, inductively coupled plasma, triple quadruple mass spectrometry. Laser ablation, the LA part of the abbreviation, is simply we're shooting a high power laser at these pieces of rock, and it takes an extremely small piece of material out and it kind of vaporizes it. It creates it into a little plume of dust, if that's the best way to think about it. And when that little plume of dust comes off this rock after you shoot it with the laser, it leaves this little crater behind. And I just want to emphasize that this crater that you're seeing here is it's about 50 microns in width. So a human hair is, about 150 microns in width. When we're using this analytical method on these artifacts, these holes that we're creating are extremely small, and therefore we call it quasi non-destructive. And this is what is opening up new avenues for us, is that we can actually test these stone tools without, having to chip a large piece off them and, ruin their aesthetic qualities or ruin any information for future generations. We're taking an extremely small amount of material and we're pushing that material through a torch, basically. This is where we reach the inductively coupled plasma section. We've got a high temperature plasma that this dust is injected into, and that plasma, it ionizes the material that's coming through there. So it's creating an ion stream. These are negatively charged ions that are entering into the mass spectrometer that allow us to do, an analytical method for determining concentrations of that material in that rock and getting at very, very small concentrations of data. So when I say small, you might be familiar with like parts per million concentration, like amount of chlorine in a pool. Someone puts too much chlorine in it, it'll make your eyes burn in the pool, right? With this, we're talking in the order of parts per billion concentration, which is a very, very small amount. And I know this is going to sound ridiculous, but with the new instrument we're getting, we have the possibility to reach not only parts per trillion concentration very well, but even reaching the limits of the technology at parts per quadrillion. And because we're able to get to those very, very low levels of concentration data, that is giving us a very good idea of the unique formation process of these rocks. The geologic process that created them is indicative of the trace elements that are inside of these materials. So in the past, when I've used laser ablation previously, the mass spectrometers that we were using, they were really good at parts per billion concentration, but you could see, when you're looking at the numbers and you've got like a number of significant digits like 0.00001, and you see that there's still more information there, but your instrument is not accurate enough or precise enough to extract that data after that last significant digit. This is where this new instrument will allow us to transcend that and get a better accurate and precise signal to interpret that unique formation history of the rock that we're looking at. And that's where the technology, the triple quadrupole, comes into play and gets us these really, really accurate numbers. And I won't bore you tonight with the intricacies of triple quadrupole, but just know that it lets us reach this really accurate signal when it's processed with the laser ablation. And of course, we're testing many, many, hundreds, potentially thousands of geologic samples, and we're testing those geologic samples to compare with artifacts. We're not just shooting artifacts alone. And the protocol that I developed, for every artifact that you test, you should be testing at least 3 geologic samples every time you do analysis. Otherwise, you're just going to be comparing artifacts to artifacts. And you're never going to be able to, get at the answer of where did this thing come from, because you're just comparing, apples to apples at that point. So this comes down to this connecting artifacts to geologic sources. And the trace element analysis I'm telling you about, that's what's really getting the answer. What I have here, this is a modified image of some of the geology of the Intermountain West. So you're looking at, here on the left, you see the Simon cache. That's out near Fairfield, Idaho, and that's a Clovis cache. And then the fin cache, that one that I showed you towards the beginning that had all those really spectacular different color Clovis points, that's coming from this, Tri-Corners area of Idaho, Utah, Wyoming. And the caches are going to be these little hexagons. The Anzac site also has a cache there. And if you notice the bullseyes that I have here, these are bison jumps. These are verified archaeological sites with bison jumps. These are in Wyoming. This is in Montana. And if you go further north, there's a lot more jump sites that are up in Canada. But, it starts showing a little bit of an interesting situation when you've got a bison jump and then caches that are in some proximity to these. Now, what are the reasons for that? We don't know yet. But hopefully with a lot of the analysis that we're doing, we can start connecting, these caches with the Clovis points in them to their geologic sources. Is it coming from a particular limestone formation that is bearing chert that developed, all the chert points that are in the fin cache? We can very easily these days do obsidian. It's highly accurate with very minimal techniques, but the chert flint sourcing is the more difficult of them because of the elemental composition. So this just kind of gives you an idea. And these are not all the Clovis sites. These are not all the jump sites. There are some that are debated, is it actually a jump site or not? Is it a trap or not? But you're seeing verified jump sites with these and verified Clovis caches with these, the Crook County cache and the Anzac cache. This actually has a really interesting material that's made out of a silicified shale. They call it tiger's chert as well. Kind of looks like a tiger stripes. So why should we use this instead of just going, oh, well, this color and texture? Well, first of all, we're trying to get a really good image of the mobility patterns of these people. And the way to get at that is by knowing exactly where these stone tools came from. Like I said, it's minimally destructive, right? It's quasi non-destructive. It's high precision and sensitivity with just putting a tiny little microscopic dot on it. And that brings you to the question of, well, the color and texture. Why don't you just say, well, all the gray points came from there, or all the tiger chert came from this area? Well, you can say that, but the problem is within the same outcrop of material, especially cherts and flints, there is a lot of variability that can occur in a local source of these materials. And I probably know this better than none other, because working in Texas with the Edwards Plateau, chert occurs throughout the Edwards Plateau. And it's a lot of it is this kind of this gray color that you're seeing here. This is actually a cache that I worked on and did some laser ablation on. This is at Texas A&M, but this is called the Hogeye cache. There's, I'm going to probably quote this wrong. There's either 58 or 55 or maybe 52 different Clovis artifacts that were in it, and they all look the same. Now we can say, oh, well, they obviously got it all from the same location. But I know that you can find the same kind of chert throughout Texas. A third of Texas, you can find cherts somewhat similar to this. So that becomes a real problem when we're trying to understand these, definite human mobility patterns in the past. That's why we have to turn to these other methods. Now, it's essential to have this geologic source database that we're building up. And if we don't have the geologic database and we're not spending money on it to get all these things tested and develop these profiles, we're never going to know where these things came from. So part of a lot of my research and getting funding for these things is to build up these geologic source databases so we can start matching artifacts to these. And the beauty of, building these geologic source databases is that, yeah, I'm doing it for Clovis right now, but we can apply all that information to any other chert or flint artifact in the region. And you start building up a bigger picture, everybody can access it then. So it'll be available to, any researchers that want to look at it. And we're trying to find, with my research, knowing how these Clovis people moved around. And that's where we're going to shift gears here in a second into understanding mammoth migration patterns as well. That point that you're seeing me hold right there, that's one of the larger points from the fin cache that I pointed out at the beginning. So we're really trying to, key in on these mobility patterns. And if we don't do this, we're not really going to understand the Clovis people and how they moved around the landscape and how they were living their lives every day. So that brings us to the mammoth tusk, like I was talking about. And I'm going to probably just fast forward a little bit through some of this stuff and not, belabor some of the text too much. But we know that these people knew how megafauna moved. They were watching the animals all the time. They were tracking them, and they came to know them very, very well and how they behaved. And because of this, this would ensure their large scale hunts being a success. Now, the question that I came up with, in addition to the stone tool sourcing and knowing where these different traps and drives are at, is looking at an animal that can tell us where are they moving from spot to spot. And that's where we need to turn to the mammoth tusk and try and see how they were moving every day of their life. Now, I'm going to give you a real quick introduction, a quick and dirty introduction to isotopes. We're talking about strontium isotopes. I've mentioned a couple of times. What is that? Well, an isotope can be a stable isotope or it'll be a radioactive isotope. Now, you've heard radiocarbon dating before, probably. Radiocarbon dating is basically measuring the ratio of carbon-14 to carbon-12. These are all carbon. The difference is that the carbon-12 is stable because it has 6 protons and 6 neutrons in its nucleus. This atom is not radioactive. It is stable. When an atom has too many neutrons in it, or more protons than it would typically have, if it has 6 and it has 8 neutrons, it's unstable because it's got 2 more neutrons. And this is the radioactive decay that's going to occur. Now, this is where it gets interesting for us with the mammoth tusk when we turn to strontium, because you can look at the percentages of the amount of carbon that are in the environment. With carbon-12, that represents about 98.9% of all the carbon on Earth. As you get down the line into the radioactive carbon, as this stuff decays, it becomes less and less over time. So the carbon-14 that's in the environment is less than about 0.1% total. And, it's for another discussion about radiocarbon dating and how it works, but just know that this is the basic idea, right? So with strontium, when we start talking about it, strontium has 4 stable isotopes, and these isotopes are important to us because they make up different percentages. And we can measure these percentages and ratios to each other and get a good idea of what kind of groundwater these animals were drinking in the past, and we can match up this with their tusks. And I'm going to show you a couple images in a second, but just know that, strontium-88 is about 82.58% of the majority that's on Earth, and then it gets less and less as we get back down to strontium-84. So the strontium, you might be asking, okay, well, these animals, were they eating a block of strontium? No, they're taking the strontium in when they're drinking groundwater. So if they're drinking out of a creek or a natural spring or whatever it might be, or even a river, that is going to have a unique strontium isotope signature. And that is getting locked up in their bones and in their teeth. And throughout their lifetime, if that thing is growing and they're taking it in, it is absorbing this strontium in that groundwater. And, because these things are radiogenic isotopes, these things are, soluble in the water. And this is going to allow us to get to the source of exactly where that animal is drinking during its lifetime. And all these things end up in that hydrologic cycle of how water's moving across the landscape. And that brings us to the methodology of, well, how am I going to do this? Some researchers have already done this with African elephants, but this is unique because I'm mapping across the Snake River Plain, and we have a really unique aquifer system and water sources I'm going to show you in a second. But you might be asking, well, why do you want to look at mammoth tusks? Obviously, because they're killing these animals and eating them. But another really, really interesting feature about mammoths is the way that their tusks grow. It is so similar to tree rings. You would think if you just saw it in cross section, like you see here at the bottom, that you were looking at a tree stump or something. A mammoth tusk is basically putting on a ring almost every 24 to 48 hours of its life. And this might be accelerated at some times of its life. It might be decreased at other times. But in general, most mammoths are putting on this ring every day. And because of the technology that we have with laser ablation, I can use that laser to focus in on each one of these rings, and I can run a beam of the laser all the way across a cross section of a mammoth tusk. And ideally, because I don't want to create too much damage to these tusks, because, their archaeological items are really interesting, I'm actually just building this up from paleontological specimens and not archaeological, because we're really just trying to track how these mammoths were moving across the landscape. So if I take my laser and I shoot it across all these rings, I'm going to start maybe seeing some repeating patterns in that strontium isotope signal. So that strontium is going to change based on what water source these animals are drinking. So if they're going from one end of the Snake River Plain to the other end, and they're traversing, it kind of looks like a little smiley face almost, the Snake River Plain, when you look at it from a satellite image. If those animals are moving up and down the mountains, or they're going across the whole plain up and down to, in search of food, remember that 150,000 calories a day? That animal movement will have repeating patterns throughout its lifetime. And that might be, you might see that seasonality appear. And because of this unique feature of mammoth tusk and our ability to get those strontium isotopes, especially if we can do it with the laser and get that whole sequence done, that's going to show us not only how this animal is moving, but also how other animals were probably moving with these mammoths. Because when you have animals migrating, they typically all migrate at the same time for somewhat similar reasons. And this idea of us being able to track how the mammoths were moving, 15,000 years ago, 20,000 years ago, we're going to start developing these patterns, and then we can start kind of filling in the blanks, connecting the dots of Clovis caches, Clovis sites, raw material sources, movement of the mammoths. And the mammoths for us are going to serve as a proxy species to offer us into these bigger insights into the other animals that were present, including bison antiquus. And, this is where we got this unique situation with Idaho and the Snake River Plain. We've got this unique geology and hydrogeology and the aquifer systems. And, all those little spots that you're seeing here on the right, these different wells, these are all places that I'll take water samples from, and I'll be able to compare those water sample sources with the mammoth tusk and their strontium isotope signature. And we're also going to be taking strontium isotope signature readings from different modern animals, probably be rabbits. It'll probably be some roadkill of different animals. We'll be taking their teeth. And, these animals are like, if we use rabbits, they're hyperlocal. So we'll have a very good idea of that local water source and what they're taking in, including from the vegetation. But that'll give us a really good idea of those stopping points along the way. So these are wells that already exist, and we can get both the wells and the pure water source, and we can get the animals in their teeth. And of course, these animals, they don't put on a ring every day of their life like mammoths do. They have it locked up in their teeth, typically once they reach a certain age. Their milk teeth are lost. They get their, especially for large mammals, they're going to have a different signature that'll be indicative of where they got their adult teeth in, but we'll still be able to track that movement pattern and figure out if these animals were migrating across the Snake River Plain. And that's where it gets really interesting. The hydrogeology of the Snake River Plain is going to let us kind of do this proxy species mapping that I'm talking about. I like to think about some parts of North America as being like an Ice Age Serengeti, like you're seeing here with this large bull elephant in Africa. This is in the Serengeti as well. You can see that when these animals are all migrating, you got wildebeest, you got gazelle, you got elephants, you got all kinds of animals that are on the move. Some animals, yes, they do stay local, but when animals are big and they're grazers and they're constantly having to eat and they're like depleting resources in an area, they're on the move quite a bit. And a lot of this is based on seasonality and climate as well. But if we can do this, this is really going to enhance our understanding of these past ecosystems and how people were interacting with these animals and what it meant to be human in Ice Age Idaho. So looking at, I kind of already covered this. I don't really want to rehash all this, but, we're looking for that Clovis communal gathering to understand hunting behavior, to understand stone tool use and shared cultural identity with these stone tools. And to get at this, we're going to look at those megafauna hunting strategies that I talked about. We're going to use the GIS like I described. We're going to look at excavation data. We're going to, do soil samples and core samples of sites that might have been burned repeatedly through time to see how people might have been exploiting fire to drive these animals. And then we'll also be looking at many archaeological sites, especially through the Intermountain West and Idaho, to compare all this data and see if we can identify any patterns. And this is kind of where you can see this multiple layers of data coming in. We got the real world situation. We've got all the different topographic maps. We've got the information on the creeks and rivers and water sources. We've got different kinds of imagery from satellites. We've got thematic maps that might be layering on things like ethnographic data and bison hunting by Native Americans in a recorded history. But we're going to be looking for in some of these places where we may not have an archaeological site, but we've got a very good candidate for a trap or a drive. We're going to be looking to see if there's anything like evidence of stone corrals or funnels or V-shaped things or arroyos that might have other features present that we can see archaeologically. And, we're taking all this information, we're bringing it to bear to understand these human behaviors in the past. And, animals are affected by fire all the time, not just human fire, but also natural fires, wildfires. This bison grazing in the 1988 Yellowstone fire, these animals were driven off these spots. People make these observations and they make these connections. And I feel sometimes like people with the Clovis culture, they don't give Native Americans enough credit at this point in time. They somehow equate, hunter-gatherers living in the Western Hemisphere at the close of the Pleistocene as being, almost upper Paleolithic in their behaviors. You got to remember that these people were every bit as smart as we were. They were as inventive and had ingenuity to solve these unique problems. I mean, people were inventing agriculture on the other side of the world in the Middle East at the same time. So to not give these people their due and try and contribute to their our understanding of their complexity and their behaviors is really a disservice to the past. So summary, bringing it all together. These are some Clovis points that are at the Field Museum. Just took a snapshot of it when I worked there many years ago. The shared cultural template, you find these Clovis points all across North America in different environments, in different climates, possibly hunting different kinds of animals. In the East, we talked about mastodons. We're talking about mammoths in the Intermountain West and in the Southwest. These are all really important sources of data to look at and try and figure out, why do we have this shared ideology? Why are they all carrying the exact same kind of toolkit? Is it because they're all hunting megafauna? Well, we know that they're not just hunting megafauna. We also know they're living this broad spectrum diet existence. You know, they're eating all kinds of stuff, you know, from frogs all the way up to mammoths. So we have to be aware and cognizant of all these little pieces of the puzzle that are all scattered around and start bringing them together. And, you know, these communal gatherings, like I said before, these were ideal situations for information sharing, for mate selection. You know, you only have a limited group of people that you can keep in any one spot at certain times a year. That's when you're going to come together and have these maybe unique communal experiences of a hunting megafauna. So by looking at the stone tool sourcing, looking at the traps and jumps, deriving these animal migration patterns, all these ideas, we can bring all these lines of evidence to bear on maybe understanding and developing ideas about these communal gatherings that I hypothesized. And I think it's really interesting because we can bring the animal migration patterns, and maybe we can even synchronize that it was a certain time of year when they would have these gatherings. And by looking at the stone tools, we might be able to see the heartland of when the people would leave their heartland and they would come to these communal gatherings and they would converge on one spot. How did they know to converge on that one spot? How did they agree on that particular place on the landscape? Did they talk about another location they might have found before that's an ideal jump or as an ideal place for a trap? There's all kinds of interesting things that can be derived from this. And some of the implications in future research, obviously, discuss all of our findings for significance for Clovis understanding and identifying areas for future research and refinement. You know, this overarching hypothesis that I have, this big idea, it's creating lots of master's thesis topics for my students. It's getting them research experience so they can get jobs working cultural resource management, working as park rangers and park archaeologists. And you know, we're using all the information that I've talked about, bringing it to bear on the Clovis culture and the Clovis people, but also realize that we can take this information and it's going to give us insight about those adjacent temporal time periods, you know, like the Folsom people that came after Clovis, maybe even the pre-Clovis people that came before them. If we can understand Clovis and not just abandon them because, oh, they're not the earliest anymore, then I think this can give us a lot of information about understanding these other groups of people in time and space as well. So I am complete. Oh, it's 7 o'clock. We're 6 minutes past. I am open for questions now. Is anybody still there?
Yes, we are. We did lose a few people, but a lot of people stayed. So what a remarkable talk. Thank you so much, Andy.
Thank you.
And I did want to just mention before we end that on the Haley Public Library website, we have the first talk that Andy gave for us called Peopling the New World, which, as I mentioned before, it has 88,000 views. Actually, just a couple of weeks ago, I was looking at it, was 87,000. So it bumped up to 88,000 in between 1 week and the next. So
oh, you're making me feel self-conscious now about whenever I mispronounced a word or something.
Oh no, no, not at all. But are there any questions, any follow-up questions that anybody has? Andy, I have a question just about mammoths and mastodons. Did they evolve in North America?
Yes.
So they did not come over on the land bridge.
Well, about 3 million years ago, mammoths and like early elephants were in Europe about 3 million years ago. And those animals moved and migrated out of Europe slowly and spread throughout Asia. And about 1 million years ago, we have several mammoth species that make their way into the Western Hemisphere. And that is going across the land bridge. They didn't have any other option, right? They couldn't swim. Yeah, if you think about the seas off Alaska, not the best place for a large animal to swim. But yeah, and once they were here about 1 million years ago, you know, we're talking about steppe mammoths that are adapted to like a tundra type of environment, really harsh. The Columbian mammoth is evolving out of those animals. And, you know, that simply boils down to Some of the animals that have certain characteristics are surviving, and the other ones don't. And some of them might be more viable mates for others that they can reproduce more plentifully, while the other ones they can't. So there's lots of variables that are involved there, but that is the general path. And then of course the Columbian mammoth and mastodon. You have over 30 genera of megafauna that die out at 10,000 years ago, where
Mhm.
they're just completely gone. And there's all kinds of hypotheses and arguments and things about that as well.
And we got a couple of questions in the chat.
Yes.
Gail asks, where is the fen cache housed, and is it available for the public to see?
The fin cache is actually housed at Texas A&M University in College Station. It is there with about 5 other Clovis caches, and they're all in a safe. But there are casts that people have made that you actually purchase them yourself with the casting lab if you ever want to buy one of them. They're exactly like the real thing. Like I've held the real ones before, and I've held the cast. Of course, it's out of a resin or a plastic, but it is exactly the same. And they're very meticulous about their coloring of those casts as well. But unfortunately, it's not available for the public to see. Occasionally in the past, it has been like we had the Paleo American Odyssey Conference in Santa Fe. I don't remember 2010, maybe earlier than that. But all the Clovis caches were brought out then, and they were available for the public to see. But
Mhm.
these things are so rare that they're usually not put out for public display. And if they are out for public display, a lot of times they'll be cast. I know the Simon cache was someone tried to steal it a couple of years ago from College of Southern Idaho because it was on display, right?
Mhm.
And they actually stole the cast, but
Oh, huh.
because someone had tried to steal it once before as well. So it's like they're so rare, and they're part of our shared ancestry, our shared human experience. And for any one person to keep them would be bad, but we also have to protect them. And unfortunately, those are not available for public view. And that's part of you know a lot of places are doing that.
Mhm.
But the best I can do is show you cast, and I test the real thing, but you got to remember, like, there's so many layers of security on these things because people want to sell them for, wealth. Because yeah, I won't go into that too much.
Let's see. Two things. Chad says that he went to Head Smashed in Buffalo Jump, and it is an excellent museum describing the jumps and processing. Then Ben says, thank you so much. Any idea whether people move slowly across the Americas or in fits and starts? In any event, how quickly could they have made it from Beringia to Tierra del Fuego? And then I know, Nigel, you had your hand up, so we'll get to you in just a moment.
Yeah, so the first one with the head smashed in, excellent place to go check out. Any of these places where you can go and walk up to these bison jumps, it's just like it's a really unique experience to think about people pulling this stuff off, right? I mean, I don't know, every year it seems like someone gets gored or run over by a bison at Yellowstone, right?
Yeah.
And you just imagine these people were like able to control these animals and guide vast herds over these cliffs. It's just it's mind-boggling to think about well, the gall these people had, right, to even do that, or to even think, hey, I can do that. I mean, it's amazing. It really is. As far as people moving across the Americas in fits and starts, that is an extremely difficult question to answer. One, because human skeletal material does not preserve exceptionally well in most of North America. Um, we don't have the same situations like we do with a lot of cave systems in Europe, where you have more Neanderthal remains than you would expect, in early Homo sapiens, things like that. For us in North America, because we don't have human remains that are that old that survive, it makes it very challenging to understand the movement of people, right? But what is really fascinating is people must have been in place when the Clovis ideology took over, because it is a very rapid expansion of an idea. And
Mm.
when we say Clovis culture, you just think cult, right? Like this was a cult. This was a group of people that had this shared identity in this projectile point technology. And it is spread from coast to coast, from 12,900, 13,200 years ago. And there's probably like a plus or minus 300 to 500 year period on that. But to think in that time and age when people were walking on foot and their communications by word of mouth, and they're spreading a technology on making a stone tool that looks like that, and it goes from coast to coast in 1,000 years.
Hmm.
I mean, that is significant. And that's what really, makes me think about people are interacting all the time throughout the year. They're all coming, it's like they're all spread throughout the environment at one time a year, and then they all converge on this one spot and they share information and they're sharing these things, these ideas, right? And, I wouldn't be surprised if it was, we'll never know this, but I wouldn't be surprised if it was some kind of religious experience as well, to have such a profound effect on them. And, what did they say and do about it? We'll never know. But we do know that they did share this idea and that they did hunt, large bison. They did hunt mammoths. They did hunt mastodons. They hunted camels and horses. They hunted all these big animals. But they also lived very diverse lives that had a broad spectrum diet. So the question is, when did they do that, right? Was this all year long they did this, or was, this kind of a varied existence of, shifting the way you do things throughout the year? So it's a really interesting thing to think about. And as far as how quickly could they make it from, Alaska down to Chile, the, you know, the sites there are topping out. I just saw a paper that came out recently. A colleague, he actually shared with me before it was published. That was this morning, about some of the earliest dates for South America. And it looks like about 15,000 to 16,000 years ago. I'd have to go back and look at it, but that might be kind of the limit, right? Now, if we have the White Sands site in New Mexico, there's been debate about it as well. But if it is at 22,000, and I personally think that it'll be hard to locate sites that are extremely old like that because they probably did not use a stone tool technology like Clovis, right? That's so obvious. They probably used maybe, in my opinion, a lot of organic materials for projectile points. They might have used like wood, fire hardened wood. They might have used antler. They might have used bone. They might have used even ivory as projectile points. We might not find that material because it's organic and it just goes away. And because of that, and we have these, remember I showed you the Gault site and the Western stem, like the Western stem is pretty obvious, right? Like that's a Western stem point. But before that, how do we have that data, right? So that'll be the really hard thing to get to. But if we have them there at White Sands at 22,000 years ago, I don't think it's out of the realm of possibility for it to be a 25,000 year entrance. So, you might be talking a 10,000 year period to get from Alaska down to Chile. But, that is a very long period of time. You think about the rise and fall of different cultures around the world. It would not be out of the realm of possibility, though, for them to take, 1,000 years to get from, north to south. But you got to remember this, and this is what's really, I hope my students get deeply moved by this because these people are coming into a landscape and an environment that no one's ever been in before. I mean, it's brand new, It's like you can't go anywhere on the globe these days that probably has not been explored by a human being, right? Or at least seen it from outer space these days. But, it's new animals, it's new plants. You've got to learn, can I eat that thing or not? If I try and kill that animal, is it going to kill me first? What things are poisonous? What things are good to eat? What tastes good? Where can I find shelter? How do I process that tree? Is this plant good for making cordage for making a pair of shoes? Like there's all those questions that people have to answer before they can move into an environment, right? So I feel like it's going to be a process of kind of pulsing into an area and exploring it and exploiting it, and then maybe pulsing back. And it's going to be kind of like this. I like thinking of it as kind of like waves on a shore, right? Like the wave of humanity just keeps kind of like splashing out and then coming back, splashing out and coming back, because people are always going to be unsuccessful too, right? Like, the dummy that eats that mushroom they weren't supposed to eat, they're gone. They didn't make it, right? So it's like, those things are always being explored by people. And I think that's the really interesting story about Native Americans, is that they're coming into new territories that have never been explored before. And, that is the true age of exploration, in my opinion, because it's all new. And I don't know, I think that's cool.
Well, and as you were talking, I thought about some of those folks who'd been caught in ice, and now that the glaciers are melting, their bodies are found, and they find them with pouches with herbal medicines in them.
Oh,
And
yeah.
when you were talking about what people didn't know about the environment, they wouldn't have known what they could have used for medicines either. They were
Right.
really in a brave new world.
Like
So,
you're talking about, like Otzi the Iceman. I think he was early '90s, '94 maybe. When they found him, his whole toolkit that was found with him, he had primitive aspirin,
mhm.
things that we'll never know about the Clovis people because we won't find human remains possibly that still have like the skin intact. Otzi had tattoos on areas where he had arthritis, like little crosses and X's. That
Mhm.
was like some type of ritualistic process to alleviate his pain. That was like a belief system that if I put this tattoo, on my wrist, I'm not going to have carpal tunnel syndrome or something like that, or my knee's not going to hurt, my back's not going to hurt. So all those things that we can't know, we're always going to see the past. And this is what I tell my students all the time. You're looking through like a very dark glass, right? And you're looking at that past, but it's always going to be like very muddied and unclear. And you're going to have to make a lot of assumptions about all the stuff you have in front of you to explain what's behind that glass. I guess that I don't know if it was Lewis Carroll, Through the Glass Darkly or something like that. Like you're not going to be able to see that pass in some way, but you can try.
Nigel, let's let you be the last voice, the last question.
I just had a question about LIDAR. I don't know too much about it, but if these, if humans have been here and animals have been here for, 40,000 years, I know we've destroyed and trampled a lot of our landscape, but would LIDAR, show not which animals, but migration routes or pathways that had been followed, or that are imprinted on the landscape, because we know that elephants seem to follow the same pathways over and over again. And if the humans were following the elephants, or getting there, we use LIDAR around like buffalo jumps or animal jumps, would those things, could we pick them up? And has anybody thought about doing that?
Well, that's where I was talking about our research with looking at like soil analysis. If that does exist, it's probably going to be buried. It won't be actually on the surface. And unfortunately for us in the Snake River Plain, we've got the Bonneville flood that happened and completely, decimated the landscape. And the people that came after that, they did have lives, but maybe those really deep migration patterns, at least for this region, it might not be present. But even in other areas, because you have a constant deposition of soil happening, and then you have it's always like an addition and subtraction process with dirt and soil, right? Like it gets added and it gets subtracted. Like this is constantly going on the landscape, and you'll have areas that'll build up really high, and other areas will get just depleted of soil. And that changes a lot, especially during the glacial period. When you have those glaciers that come down into Idaho and, they're scratching the landscape and they retreat in like Cooper's Ferry, that area, before then, it had glaciers that were probably covering it to some extent. And then they retreated and the people were living there at Cooper's Ferry, right? And the glaciers never came back. So having some of those patterns, it would be extremely difficult to find with LIDAR, but LIDAR is very good for like more ancient civilizations like the Maya, looking through tree cover, things like that, looking for road networks in the American Southwest. You can still see some of those road networks that people took. But once you start getting back in time, past, I'd even say 5,000, 6,000 years ago, a lot of that stuff starts getting obliterated to some extent. It's either covered up or it's erased. And unfortunately, that's just a part of archaeology, right? Like we're never going to have 100% recovery of anything. Even Otzi, you know, he was buried in ice for 5,000 years, and he's still not perfect, right?
Yeah.
A lot of his stuff was really messed up, but I mean, he was completely encapsulated, and you know, we can't recover everything from him. So unfortunately, we have to turn to these other methods, and we can't use Lidar for what I'm trying to do anyways.
Thank you.
Yes, sir. Thank you.
Great. Well, thanks, Andy. This was
Yeah,
again a wonderful, wonderful talk. It was exciting to hear about your new research, and it sounds like you're heading out on many, many different exciting paths. And any thought about when some of this data will start to bear fruit, and you might be getting some answers to those questions that you posed?
Yeah, definitely. I'm starting excavations at a rock shelter this summer, and we're having our instrument, the rest of it, delivered in May. And after I get back from the field, I'll be working in the lab for a couple months in the summer. And then I have a student starting to process samples for me, and we'll start using the instrument for stone tool sourcing. And probably another year or two before we get into the Mammoth tusk sourcing. And that's going to be a whole other can of worms. But initially, we know that we can do stone tool sourcing. It's very accurate. If you remember that image I showed you towards the beginning of the little starburst looking patterns, all the stone tools, it's highly accurate for that. So that should bear fruit at least with the next year or two. And, that'll end up coming out in publications and, you know, more public talks like this. So, and I'm probably going to be giving a very similar talk next week at the Herritt Museum. The Herritt,
Great.
yeah,
Yeah.
probably be this pretty much the same talk, but it'll be in person, and they won't be recording it or anything.
Great. Well, I'll do a little bit of editing on this, basically just putting titles in the front and the back, and we'll post it up on our website, hopefully within a week, if all goes well. So,
I
yeah.
really appreciate everybody tuning in and listening, and thank you so much, Kristen, for everything that you did putting this together.
Yeah, and thanks everybody for showing up too. So, oh yes, indeed.
Thank God.
Yeah. All right.
All right, y'all have a good evening.
Uh-huh. Bye-bye.